Hey everyone, we're back with page 2 now of the thermo outline, and we've got some information here on the page that I just wanted to put here as a reference. Some conversion factors. 1 calorie is equal to 4.184 joules. 1,000 calories with a lowercase c is equal to 1 calorie with a capital C, which is also sometimes called a food calorie, and sometimes called a kilocalorie. And then 101.325 joules is equal to a liter atmosphere. Okay, now let's start to quantify some of the stuff that we've been talking about. Quantify meaning numbers are going to get involved. We can calculate heat with the equation Q equals mc delta T. Okay? Now, what are each of these terms? Q is heat. M is mass. Delta T is T2 minus T initial, although I was taught T final minus T initial. I think it's a better way to think about it. And C can be called either the heat capacity or the specific heat. Okay, now let's do two definitions for heat capacity. First, what we will call our ghetto definition. It is how well a substance holds heat. Now, water has a very high heat capacity, and metals have very low heat capacity. What that means is a metal, when red hot, is held up in the air, it's going to cool down relatively quickly. It does not have the ability to hold on to that heat well. It transfers it. Water takes an incredibly long time to heat up and an incredibly long time to cool down. And that is the reason that people like living near the coast, because the climate is more temperate. If it gets to be cold outside, heat's released from the water. If it's really hot outside, water absorbs that heat, and the average temperatures at the beach seem to be much steadier and quite a bit lower than in downtown or the valley or something like that. Now, the technical definition for heat capacity. The amount of heat necessary to raise 1 mole of a substance by 1 degree. Now, that is the Celsius degree or the Kelvin degree. They're the same size. The person who taught me thermo ditched saying Celsius, Kelvin, and just started using the word degree. Because when you're talking about a change, 1 degree in Celsius is a 1 degree change in Kelvin. Okay? So it helps to clear things up. Now, the magic word in this definition is mole, because specific heat is the same definition, except instead of moles, we use grams. Okay? The amount of heat necessary to raise 1 gram of a substance by 1 degree. Okay, work. Like we said before, work is a force times a distance, a force acting over a distance. But in a chemistry class, we're not pushing, cars up inclined planes and stuff like that. So our definition, negative P delta V. What we're really talking about here is the expansion and contraction of gases. Okay? Cool. We will probably not actually have to calculate that so much. Don't worry about it. Energy. In this chapter, we're going to refer to both kinetic and potential energy. Okay? It is probably important to note that 1 joule is the equivalent of a kilogram meters squared over second squared. Okay? Now, kinetic energy is the energy due to motion, which is calculated as 1/2 the mass times the velocity squared. Okay? Now, potential energy is positional, or some people will say the gravitational potential energy. And that potential energy is calculated by mgh. Let's look at units. Mass, kilograms. Velocity, meters per second quantity squared. That's a kilogram, meter squared per second squared. That's a joule. Now, potential energy, mass, kilograms. G, the acceleration due to gravity, okay, is going to be in meters per second squared. And the height is in meters, so we have kilogram, meter squared per second squared, which is a joule. The same either way. Okay? Now, we can talk a little bit later, next page, about how these two will actually interrelate with each other. All right, state functions. Trickier concept here. What's a state function? A function that is independent of path. It doesn't matter how you get there, you just get there. It's the difference between the beginning and the end. Energy is a state function. So what we can say is to calculate an energy change, delta E, we can go E final minus E initial. Okay? Initial. All that matters is the first value and the final value, and you take the difference between them. Okay. That's it. That's page 2. When you tune back in for page 3, we're going to do some mathematical examples.